Okay, today we're going to look at the sine law. This is trigonometry that you haven't seen before, and there's sine law and cosine law that we're going to use in this unit, and they're both used for triangles that don't have a 90-degree angle. So all of the SOHCAHTOA stuff we did only works for a 90-degree angle triangle. So what we're going to do is figure out how can we solve these triangles when they're not a 90-degree angle. So before we get to how to do that, let's just take a look at this example and let's try solving it like we did in the last lesson by using multiple triangles. So this one isn't a 90-degree angle triangle, but let's suppose we took the triangle, we divided it into two like that. So we did questions like this the other day, and then let's see if we could actually solve it for that missing angle. So how we would have approached this the other day is we would have said, well, we need to first figure out what that height of that triangle is, and then we should be able to solve it from there. So let's do this one first. So we would have had sine 35, right? Sine of that angle. Opposite of 35 is the x, and hypotenuse was the 10. Okay, so I picked sine just because I knew it, but if you weren't sure, just like we did yesterday, remember always go from the sine, go straight across, figure out your opposite. Once we have the opposite, we got the hypotenuse, so then it has to be sine. We can't use cosine or tangent. Okay, so we'd have that answer, but instead of actually solving it for the answer, right, if we were to solve this, we would go 10 times sine 35, and that would give us our height. What I want to do is, let's see how we would solve the other part of it. Actually, before we do that, let's actually rewrite it. So x would equal 10 times sine 35. And let's get the answer while we're at it. So we'd have 10 times sine 35 is 5.7. Okay, so that's how we would have done it yesterday. Then the next step would be, let's figure out the missing angle that we have here. So we have opposite again and hypotenuse, so it would be sine again. So we'd use sine of the angle we're looking for would equal our 5.7. But instead of writing it as 5.7, I'm going to leave it as this step. So it would be 10 times sine 35. Okay. And so that would be our opposite, and then we would divide it by 12. So we could do it by breaking it into two triangles and then finding the one missing side and then using that answer to find the other angle. So in this case, we would go 10 times sine 35, which is our 5.7. We would divide it by 12. That would give us our answer, and then we have to go second sine of that, and we get an answer of 28.5 degrees. And I actually would round up to 28.6, and let's even round it up to 29. That's close enough. So 29 degrees would be our final answer for this question. Okay, so I'm not worried so much about the answer today. What I want to do is figure out how does the process work. So if you actually, let's backtrack a little bit. Let's go back to this step right here. Okay, and I want to change it so that it looks sort of the same on both sides. So what I'm going to do is I'm going to take this 10 and I'm going to move it down, because remember, because we have fractions, we can kind of cross multiply without really changing anything. So I want to change it so that we'd have sine of the angle that we're looking for divided by 10 would equal sine of the 35 divided by 12. And I'm just writing this for a particular reason, because now what I want to do is I want to go right back to the original question to see, could we have got to that step first? Could we have figured that out without doing a lot of extra work? So let's go back to the original question. I'm going to get rid of all this extra junk in here. And you can see that the original question was, what was this angle? You can see we have all the important numbers in the question. We didn't have to find that height of 5.7. So if you look at this question, let me just kind of draw some things in here. From our angle, we've got our side across from it is 10. So because it's opposite, we're going to typically use sine. So you see you can write it as sine of the angle divided by the opposite side of 10. So sine of the angle across from it is 10, and then we have sine of 35, its opposite is 12. And we don't have to worry about the hypotenuse, like in a right angle triangle, because they're no longer right angle triangles. We just need to worry about the angle and the side opposite to it. So that's going to be a way faster way to solve these kind of questions instead of having to break them up into multiple triangles and do it in 2 steps. So for this one, because it's opposite pairs like that, we can just use the sine law, and we'd write it as sine theta over 10 equals sine 35 over 12, and then we would cross multiply it to solve it, and we'd get the exact same answer. Okay, so before we do some other examples, I just want to look at how the sine law works. So we'll go back. There's the same question we just did, and the sine law can be written in 2 different ways, and it doesn't matter which way you write it, and when you look at it, it looks complicated, but I want to break it down for you here. So first of all, in our regular triangle, right, our ABC triangle, we just got to remember that A and the little a is the side across from it, angle B, little b is the side across from that, and C as well. So the sine law states that we can calculate these by going A divided by sine A has to be the same thing as B divided by sine B, which also has to be the same thing as C divided by sine C. Or the second formula that I've got at the bottom here, it's the exact same thing but written the other way around. So you can do sine of the angle A divided by little a, sine of B divided by B, and so on. And it really doesn't matter which formula you use. You just pick whichever one you want, and some people, they like to use the top version when you're looking for a side, and some people like to use the bottom version when you're looking for an angle. But it really doesn't matter which one you use. Okay? And the second part that you got to be aware of is we're only ever going to be solving it for one angle or side, so you're not going to have to do all 3 parts of the equal sign. You basically just pick 2. So you would use the A equals B section, or you could do the B equals C section, or you could even do A equals C. It doesn't matter. You can pick any 2 parts of the formula because they're all equal to each other. It makes it a little bit easier to work with. Okay, so let's kind of redo this question now again using the sine law formula and see if we can get it to work. So in this case, there's our exact same question that we just solved. Let's use the bottom version because we're looking for an angle. Okay, so what you want to do then, let me erase the middle one. It doesn't matter, like I said, which one you use, but let's use the bottom just to pick one. And what we want to do is we're only going to use 2 parts of it. So it doesn't matter which angles you use. So let's just, to make it easier, let's call this one angle A. So that means the 10 would be side A. And then we call this one angle B. That means this one would be side B. So we have A's and B's involved. So our formula that we're going to use then is only the first part of it. We're not going to worry about the rest. Okay? So there's the formula we're going to use for the sine law, and you'll see we'll get the exact same thing we just did. So we'd have sine of angle A, which is the theta, divided by side A, which is 10, and that's going to equal sine of B, so sine of 35, divided by letter B, which would be side B, which would be 12. And that's it. So that's how we're going to use the sine law to solve this question. Take a look at that. Let's just do a quick back step to the previous page. And you can see up here we get the exact same formula. So it will work. I just wanted to prove to you that the sine law is just sort of a shortcut of regular SOHCAHTOA. But we're going to use this more often because it's a lot faster. So sine of the angle divided by 10 equals sine 33 divided by 12. And all we have to do now is cross multiply to solve. So on your calculator, the first step is get that 10, right? We don't want the 10 there, so let's times that up by 10, so the 10 will go up top. So you'll have 10 times sine 35 divided by 12. You can do that on your calculator. Go sine 35 times 10, hit equals, divided by 12. That gives us 0.47. and then go shift sine of that answer, and you get 29 degrees. The same answer that we had on the previous question. Okay, so that's how the sine law works. It works pretty good. Let's do a couple more quick questions just so you can kind of understand it a bit more. So it doesn't matter how the triangle is given to you, and it doesn't matter whether you're looking for a side or an angle. So let's suppose that's 53 degrees, this one's 68, this side is 22.5, and let's find this side down here. Okay, so the question is, can we use the sine law to solve this? So the key thing you want to remember for the sine law is it has to be a side and an angle across from it. So we've got our angle of 53 and our x across from it, so that's good. Because we're looking for a side this time, let's write it in the other version. So we'll put the side on the top. So x divided by sine 53. Okay, and then that'll equal our 22.5, because that's our other side. Divided by the sine of 68. Okay, so this is where you got to be careful. I intentionally tricked you on this one. So we have our 53 and our x across from each other, so that's good. And we have 22.5 across from, I wrote 68, but the 22.5 is not across from 68. So we can't do it, right? We can't have the 68 in there. So does that mean the sine law isn't going to work and we can't do the question? No, what it means is we actually have to figure out this angle here first. Once we have the angle, then we're good to go. Does that mean we have to use SOHCAHTOA or something else? Thankfully no, because we know it's a triangle. We know a triangle adds up to 180 degrees. So all we have to do is figure out that missing angle by going 180 minus 53 minus 68, and that's going to give you the answer to the missing angle. So when you do that on your calculator, you get an answer of 59 degrees. So that means that missing one in the bottom is 59 degrees, and that's the one we're going to put in our sine law formula. We have to use the 59. And that's it. So we've got our side set up. So you can see I really didn't use A, B's, or C's the way the formula is, which is fine. You just have to make sure you follow the same pattern. So side divided by the angle across from it equals the side 22.5 divided by that angle across from it. And once you've got that set up, you're good to go to cross multiply. So in this case, we want to cross multiply the 22.5 times sine 53 first, and then divide it by the 59, sine 59. So on your calculator, go sine 53 times 22.5 and divide that by sine 59. Hit equals, we get 20.96, so let's just round it to 21. And we're done. So that is another good example of the sine law, and you can see really the only trick to this one is we had to use the 180 rule to figure out that missing angle. So the key idea for any of these questions, make sure you do the side and the angle across from it when you set that up in your formula and cross multiply to solve. Before we quit, I just want to show you that actually the sine law does indeed even work for a 90-degree angle triangle. So when we did a 90-degree angle triangle, let me just do one of these quick. So if I gave you an angle here of 30 degrees, and let's suppose we had a side across from it as being 10, and let's suppose we were looking for the hypotenuse. So let's solve it using SOHCAHTOA first, and then we'll solve it using the sine law and show you that they're pretty much the same thing. So if we do SOHCAHTOA, we would have done sine of 30. Right? The reason we use sine is we have opposite and hypotenuse. So we'd add sine 30 would equal opposite over hypotenuse, so it would be 10 over x. And then to solve it for x, we would have had just traded the x and the sine 30 around. So we'd go 10 divided by sine 30. And on your calculator, go 10 divided by sine 30, gives you an answer of 20. Okay, so that's the one way. Now let's actually do the exact same question again, but let's use the sine law. So our sine law, we'd have side 10 divided by the angle across from it, so that's sine 30, and that would equal our x, what we're looking for, divided by its angle. And we know that because it's a 90-degree angle triangle, the side across from it is sine 90. Okay, so it looks different, but the trick to this one is what happens if you actually figure out what the sine of 90 is. So on your calculator, if you type in sine of 90, you get 1. So sine of 90 really is just a trick to equal to 1. So now if you look at this formula, we get 10 divided by sine 30 equals x over 1, or just x. Now you can see it's the exact same formula that we did with SOHCAHTOA. So really a SOHCAHTOA is just a shortcut for the sine law. It's just a special case that we have a triangle with one of the angles being at 90 degrees. You can see it gives you the exact same thing either way. So the sine law will work for every triangle, doesn't matter whether it's a 90-degree angle triangle or anything different. That's the good news, and you can see the calculations. You can see the calculations are exactly the same, and you get the exact same answer. So we'll stop there. I want you to do some practice questions on the sine law, and we'll move on from there later on.